Let me consider a new graph with 5 vertices. Let me call them A, B, C, D, and E. And then let me put some random edges here and there so that every edge has some incoming links and some outgoing links. So this is my graph. Fine. And now let me create a table for these A, B, C, D values. And then start off with some values for A, B, C, D, E. I divide my resources equally to A, B, C, D, E. Resources are gold coins, as in the previous example that we have seen in our lectures. So what will that be? It will be 1 by 5, 1 by 5, 1 by 5, and 1 by 5. Correct? So if I continue like this, we observed that it converged for 3 nodes. Now I have taken 5 nodes. Not so easy looking graph. Will it converge here as well? Is my big question. Will it converge here or not? Let us go to the Excel sheet and then the Google spreadsheet and then try doing the same thing that we did before, and we'll see whether it converges or not. So let us be prepared to go and edit there. Let us observe what's happening here so that the punching in of the equation will be easier for us. Now look at this. A is actually equal to C by 3. Correct? Why is that? From C, you see that there are 3 edges going out. So the value of C will be divided between these 3 people. So I will say A equals C divided by 3. Good. Next. B is A plus E by 2. You can check why. Maybe you should pause and then check for each and every value. I have written it down. I'll just go through it. It's for you to check whether it's right or not. B gets all the value from A. It also gets half the value from E because there are 2 edges going from E, as you can observe. Okay. So C will be B because there's only one thing that's coming inside C, and B sends only one edge to C. I mean, from emanating from B, there's only one edge. And then D is C by 3 plus E by 2. You can check why. And finally, E is equal to D. So we'll keep these things and then try to go to our spreadsheet and then try to code it. So what I'll do is I'll directly go there to the spreadsheet, finish this assignments of A, B, C, D, E, start with 1 by 5, 1 by 5, 1 by 5, and bring you people there and then show you as I pull down the values on Excel, on Google spreadsheet. You'll observe that I'm populating everything and we'll see whether it converges or not. So I forgot something here. So let me just write that down. E, as you saw, has incoming link from C as well, not just from D. So you have an incoming link from C. So let me make a note of this. E is not just equal to D, it is plus C by 3. A good way to see if all of them add up to 1 is to see if these things add up to, if these 5 things add up to, if you add these things, you must get, what should you get? Guess? You must get A plus B plus C plus D plus E. See if you're getting this. And you just think of how and why exactly do I say they should add to A plus B plus C plus D plus E. It's a simple quiz question. I have now opened the Google spreadsheet, and the values of A, B, C, D, and E, as you would have guessed, starts from 1 by 5. So I'm going to populate it with 1 by 5 throughout. And as we computed in our previous lecture, the value of A is going to be C divided by 3. I think you all know how Google spreadsheet works. As I told you earlier, you just need to take the value of this, which is C column and the third row. You should in fact punch in is equal to C3 divided by 3. Okay. And then what was B? B was simply same as A plus what was in E divided by 2. Isn't it? Okay. What was my C? My C was nothing else but B. You may want to take a look at my previous lecture if you are not following what I'm doing. It's a pretty straightforward process. My D is going to be, D was slightly complicated. It was C by 3 plus E by 2. That's it. And what was E? E was equal to my D plus C by 3. A good way to check whether it is right or not is just to see if it's equal to the entire row. Is this equal to A4 plus B4 plus, what is that? A4 plus B4 plus C4 plus D4 plus E4. It should be 1. Perfect. Which means the values are properly put. Let me delete this now. Okay. So now what I do is I copy this and paste this, and this creates a new iteration. As you see, the value of this changes, but this value remains the same because it's simply again 0.2 by 3, C by 3, and so on and so forth. Let me just pull this and see whether it converges or not. It is no way converging. Maybe it doesn't converge. I don't know. Let me go ahead and see. Well, I see something promising. It looks like it's converging. You see 0.07 and 0.07 here, 0.21 and 0.21, although the third decimal digit, it is not changed, it is something else. I sort of see a ray of hope here. Maybe it will converge. Let me go on. The point is to keep going until you get the same values. It looks like it's converging. You see the last three decimal digits after the point looks like the same, but I'm not really happy. I want to see the exact converged values. Let me go on. I go on and on. I'm still not happy. Let me pull this to, let's say, as you can see, I'm in 76th row. I have repeated this 76 times. If I go on to, let's say, 200 or let's say a little over 100, I see that the values are exactly the same, right? It looks like it's exactly the same. When it's exactly the same, no matter where, until what point I go, I'm going till 250, it will still be the same. You see these two cells? It was so much and it still remains the same. Let us make a note of this. We are observing that the graphs here, given graph here with 5 nodes A, B, C, D, E, when you start with 1 by 5, 1 by 5, 1 by 5, it is converging, right? It's converging to these values. Okay. So let's go to the next lecture and see what can one say about this, why exactly this is happening.